All right, so now that we have talked about fractions and decimals, we can finally talk about percent. Now, percent comes in the roots of the word percent. It literally means per 100. So 5% means 5 per 100, or 5 out of 100, or 0.05. 12% means 12 per 100, which is 12 out of 100, or 0.12. And so a lot of times we come up with, ways of coming between percentages and decimals and fractions. This is the same thing as 25 out of 100, or 0.25. 50% is the same thing as 50 out of 100, or 0.50. 75% should be 75 out of 100, or 0.75. And oftentimes we think about percentages as equivalent to certain fractions. For example, 50% we often think of as synonymous with half, and that is because it literally means 50 out of 100, and 50 out of 100 and 1/2 are equivalent fractions. 25% means 25 out of 100, which is an equivalent fraction to 1/4 or 1/4. 75% is 75 out of 100. If you divide 75 by 25 and 100 by 25, we get an equivalent fraction of 3/4. 10% is the same thing as 10 out of 100, which as an equivalent fraction is 1/10 of something. So really quickly, if I gave you a box and I said shade in 20% of it, well, that is the same thing. 20% means 20 out of 100. An equivalent fraction, if I divide top and bottom both by 20, is 1/5. So 20% is 1/5. And so if I want to shade in 1/5, we go back to our fraction drawing shading skills. If I said shade in 60% of something, well, we need to know that 60% means 60 out of 100, which is the same thing as 6 out of 10, which is the same thing as 3 out of 5. If I wanted to come up with, again, equivalent fractions, chop this thing into 5 equal pieces as best you can, and we would shade in 3 out of those 5 equal pieces, because that is equivalent to 60 out of 100 and 60%. All right, a little mental math. So we're not going to do all of this activity. This one says, what is 45% times 680? No, 45% times 680, that is the same thing as 45% of 680. We went over that previously, which is the same thing as 0.45 times 680. So if I wanted to do this problem, this is the method we just went over. Let's do 680 times 0.45, and this is the laborious way to go about it, where we say, let's do 5 times 0, and that's 0. Now 5 times 8 is 40, so we put a 0 and we carry a 4. And now 5 times the 6 should be 30, and we add the 4, and we get a 34. Now when we move over, you start by adding a 0. This is the standard multiplication algorithm. Now 4 times 0 is 0. 4 times the 8 should be 32. So we put a 3 here, and we bring the 2. Now 4 times 6 should be 24, and when we add the 3, we get 27. And when we add down, we get 0, 0, 6, and then 3 plus 7 is 10, so we put a 0, carry the 1, and the 1 and the 2 is 3. Now, in this original problem, there was 2 decimal places, so I need to put in 2 decimal places, and we also went over that. So, somewhat of a tedious problem. However, there's a lot of other ways to solve these problems. Sometimes this is also thought of as a table method. If I want 45% of 680, we can just use our reasoning about fractions, right? So if I say 100% is 680, well, 10% is 68, right? Just divide both of them by 10, right? 10%. And so if I double that, that means that 20% is, well, it's double 68, 136. Double this again. 40% is 136 and 136. That should be 272. Now, I'm up to 40% is 272, but I want 45%. So let's take our 5%, our 10%, cut it in half. So 5% should be half of this, should be 34. So 45% should be 40% plus 5%. So I take 272 and I add on 34 and I get 306. Or another way to do this problem, I could say 50% is, now what's 50% of 680? That should be half, so that's 340. Now if I divide both of these by 10, then that says that 5% is 34. But what's 50% take away 5%? That should be 45%. So if I do 340 take away 34, I would get 306. So using our reasoning, we can come with the same answer, and oftentimes with much less work. All right. This next one, it's a similar problem. It just says, what's 55% of 120? And in here is the way that a student went about it, and it's really similar to how I just went about the last problem, which is, 50% is 60, 5% is 6, and so if I add those two things together, I get 55% is 66. Now, the real question is, does this method work? Is it legitimate? And whenever we come to some new thing, you always have to make sure that what you're doing makes sense. And so this section has you actually, write equations that correspond to what's happening here. And when we do so, we will actually see some of the rationale. 55% of 120, that is the same thing as 0.55 times 120. But I did it as 50% and 5%. So the first thing I'm going to do is write this as 50% plus 5% times 120. And now you might notice that I can actually take this and distribute it to both of these, because that is the distributive property. And then we get 0.50 times 120, 50% of 120, and 5%, sorry, that should be 0.05 for 5%, 5% of 120. And so this should be 60, and this should be 6. And so really in doing this table method, I was using the distributive property. Now, this next one I'm not going to do at the moment. It says class activity 4M, and these problems right here, I'm actually just going to assign for some of your homework. So again, you could use a standard algorithm, you could use these other mental math strategies, you could use table methods or reasoning, but no calculator, and I'm going to ask you to figure out what these values are again without a calculator. All right, more reasoning about drawings and percentages. And again, these directions say determine the percent that is shaded. Now, for the first one, we'll do that together, and then these other ones, that again is going to be part of your homework. So looking at this first one, if I can say how much is shaded, well, I'm going to think about these things in terms of fractions, and then I'm going to turn my fractions into percentages. So if we zoom in on this first one and we say, how much is shaded? Well, I have a whole rectangle, and that's 1, 2, 3, 4, 5 equal pieces. So this is 1/5 of the whole rectangle. But we already saw that 1/5 is equal to 20 out of 100, which is the same thing as 20%. So this is 20%, this is 20%, this is 20%, this is 20%. This was half of one of those, so that should be 10%. And this is half of that, so this should be 5%. And so now we can actually count up what we have: 20, 40, 60, 80, 90, 5%. Or you could just see what's missing, which was we're missing 5%. So 100% take off 5% should be 95% was shaded of this first one. Right? We did this stuff before when I could tell you, what fraction is shaded, but really it's just turning those fractions into percentages. So what percent is shaded in number 2, 3, 4, and 5? Again, that is one of your homework problems. Now, next activity does the same thing, where it sort of merges the table method and the picture method to help us come up with these sort of things. So again, this first one we'll do together. These last few are going to be homework problems. And this says, what is 95% of 80,000? We could do 0.95 times 80,000, but that is not the point of this problem. Table method says, if 80,000 is 100%, then 10% should be 8,000. 5% should be 4,000. So if I do 100% take off 5%, I should get to 95%. So 80,000 take away 4,000 should be 76,000. Table method. Now, how we could do that here is, I assume these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces, which makes each one of them 1/10. And so if this whole thing represents 80,000, then each of these is 8,000. So this is 8,000. This is 8,000. All of those are 8,000, which would make this 4,000, and which would make this piece that we're missing also 4,000. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces, each with 8,000. So that would be 80,000. Again, take away the 4,000, leaves us with 76,000. So percent tables are helpful. Area models are helpful. Standard algorithms are also helpful, but they're not oftentimes the quickest. So that, I think, is it for this video.